So let's go for join. Join is done, merge is done. Now we have a lookup. Okay. Where is the join? So lookup also same functionality. Lookup is also used to join two or multiple tables or files and tables together. Okay, but there is some other significance for this lookup. Okay, let's take the same employee and department and we will do the lookup. So where are the jobs done yesterday? The department join. Okay, I'm taking employee and department and then add the parameter set we are using. Add the parameter set we have been using. Okay, now you first attach first you attach the employee link. So this will be a main link. Okay, which if when you attach the second link, that will become a child link, which is nothing but reference link in lookup. Okay, so in the lookup, this is a new link, right? So previously you did not see what is this link. So reject link will have a big lines, and there is a small gap, big lines with gap. But this is a very small lines with a small gaps. This is called reference link. So this is a main link. Main link is nothing but it is a stream link. So this is a reference link. So in data set you have three types of links. This is a stream link, reference link, and another one is a reject link. Okay. In lookup, reference link is nothing but it is a child table. Okay. We give output file and then we can see the properties of lookup. So here I will add the parameter set out path slash cup dot release. Okay, so here you see it looks little different. UI. Okay, user interface is different. Then join, merge and other stages. So left side you see input tables. EMP is a input link 1. Department is a input link 2. So right side you see this is a output link on the right side. So the upper one is main table, bottom one is a child table, right one is a target link. Okay. So you can move up and down, you can do whatever you want here. Okay. In lookup. So previously we were selecting department number as a join key. So here also all you need to do is take the department number and put it on the department number. Hold your left click on the department number and put it on the key expression of department number. See, it got matched. So it is matched, right? So now you take all the output columns from employee number, and if you want, you can take all the columns from department number also. So department number already exists. I don't want it. I just want department name and location. Lookup is also nothing but a join. Okay, join concept only, but it's a different stage with a different for different reason. So do the join based on the key column. Just drag and drop the columns, and then take the required columns from the child table. So all we need is a department name and location. That's why we are doing a join, right? why we have to go for join and merge or lookup to get the other details. That's it. Okay. So here, if you go to on the top left corner, you see this yellow color. Look, constraints. So this is the key here. Okay. So this is like a lookup on failure. Okay. So when master table is, for example, let's assume there is a 50. This is a department number 50. So when master table is when master table is looking for a value and it's not found. So what do you want me to do? Do you want me to continue? If you continue it, lookup is a failed for the record number 50. If you continue it, it's a left outer join. If you drop it, then it is a inner join. If you fail it, fail means job will fail. If any of the row doesn't match, so if any of the row doesn't match with the child table, job will fail. Okay? Or else reject. If there are any unmatched rows, then reject into a file. Condition, don't worry about this condition. I will talk about this condition in transformer. Okay, here you'll get confused. Ignore this condition, but this is the lookup failure option you have to play with. So continue is a left outer join. So in batch we have a unmatched master mode. Similarly, we have a lookup on failure. Continue, drop. Let's do a drop, for example. Drop should will work as a left outer join, and you have done the mapping and you have given the key column. That's it. Excuse me. So compile. So output will be same both in records. There won't be any change when you do join, merge, or lookup. There won't be any change in output, but the performance you have to choose which one to use, when to use. Okay, so there won't be any change in output. If you look at the output, loading, just one minute. Okay, see, there is no change in the output. Output would be same, whether it is a join, merge, or lookup. Concept is same for three stages. They were used to do join only. Okay, so here, let's say now lookup supports unmatched records from master table, not from the child tables. Merge supports reject link from rejected data from child tables, but lookup supports only unmatched data from master table. You can have n number of child tables or reference links. Reference links are reference tables. Okay. So see, this is a reject link. So how many reject links lookup will support? So when it is supporting rejected data from master table, that means there will only be one reject link. That's it. If you try to give any other links, it will not take it. So why do you need a more reject links when it is rejecting data from one table only, right? That's it. In this case, we do not have any unmatched data. Every record is matching, right? Lookup underscore reject dot ds. Here you need to, when you give a reject link, here you need to select the lookup failure equal to reject option. Because you given a reject link, right? You are telling I capture all the unmatched records from main table into a reject link.
Yes, I have a question.
Okay,
So now in the condition, you change the lookup failure to reject, right? So
right.
what type of join does it behave now? Because we didn't mention any drop or continue, right?
Inner join, it will work as so. If it is matching, if it is rejecting unmatched records, that means it's an inner join. It is working as inner join.
Okay, thank you.
Okay.
Yeah.
Continue means left outer join. All the records will be when to goes to output. Rejecting, we are rejecting something means unmatched.
Okay,
That is nothing but inner. So lookup supports inner join or left outer join, right?
okay.
So now let's go back to our performance tuning. So now here we need to apply different partition techniques. So yesterday, so okay, hash partition. How hash partition was working? So if I have my input like 10, 10, 10, 20, 20, for example, I'm just taking randomly 30, 30. Okay. So this is my job is running on node 1 and node 2. So if I apply hash partition, which records will be in node 1?
10, 10 will be on the node 1.
Okay. In node 2, 20 and 20. Third set of a group I will start again from node 1. So if you have any 40s, then
Okay.
40s will be in node 2. This it will just randomly distribute, right? Okay. So this is a hash partition. So why hash partition is fast for join? Because group of records are available in one node. So join will happen for group of records at a time. If you put 10 in 110 in one node and another 10 in another node, it's easy to hard to find. So like as we spoke yesterday, if you put the same color balls in two different pipes and if I ask you to pick up, it's hard for you to pick up from two pipes. But when there are all in one place, in one pipe, then it's easy for you to pick up, right? So same thing. Okay, system also can understand easily when you put a hash partition for join. So group of records will be joined together easily. That is nothing but hash. Hash is nothing but groups. Groups and groups of data will be kept in the nodes. That is fine. So but when you apply entire partition, what is the output? Entire. Entire partition is nothing but name itself is the entire. Entire data will be copied to both the nodes. Okay, so here in this our scenario, 10, 20, 30, 40 in our reference link. There are only 4 records because our child table is very small. Okay, if I apply entire partition, what will happen? So all the records will be available in node 1 and node 2. So when you are doing a lookup, what lookup happens? Let's assume my master table is having 1 million records, but my child table is having only 4 records. When you are doing a 1 million records against 1 lakh records, for example, less than 1 lakh records, and if you put entire partition, so master table data will come to, let's assume master table is having 1 million records. So out of 1 million records, uh, 5 lakh records will be distributed and sent to node 1. So all the records are available for child table in node 1 while it is doing a join. So it 500,000 records don't need to go to another node 2. Okay, half of the records will be goes to node 1 and join and get the required value. Another 500,000 goes to another node and get the required values. So but this technique works when you have a small amount of data in your child table or reference table. Okay, understand my point? So when you have a master table huge but your child table is very small, then you apply entire partition. Okay, so because while it is searching for a join, it won't go to another node. Everything, all the records are available related to child table in node 1 and node 2. So join will work faster. Okay, so here you need to explicitly mention for join for lookup reference link, you need to apply top left corner. You need to go to properties input. For department is a link, child link. You need to apply entire partition. The entire. You don't worry about the sort and all. Entire partition you need to apply. It doesn't need any key. Hash partition require a key, but entire partition doesn't require a key. Yesterday, what happened? I applied entire partition for join. And it ended we ended up with duplicate records because same data is available in all the nodes and it is generated duplicates, right? Instead of 4090 records came yesterday. Now you see there won't be any change in the output, but the performance wise it will work faster if you apply entire partition for the reference link. Now you understand what is the entire partition does, why it is used.
So usually lookup will use entire partition technique, right?
You have to, if you don't give a explicitly, if you don't mention, it will try to use it on the back end. Otherwise, it will be auto partition if you don't select it.
Mm-hmm.
Okay. So you have to tell it. If you don't tell it, automatically it will choose. Depends on the data.
Okay.
System algorithms will run. Okay. But it's better to mention it. Okay. So lookup. Okay. So in lookup, we have three types of lookups. This is a normal lookup. Okay. So caseless. Okay. Whether it is a characters, range. We have a three lookups. Okay. Equal or caseless, both are same. Okay. Range lookup. Range lookup means, for example, I'm having some date values. Okay, here we don't have a such a data. So, for example, I want to search the value between this and this. Okay, so if you double click here, when you select range, and if you double click on key expression, okay, if department number is greater than or equal to department number of employee number and less than or equal to this. Okay, so I want to search the values between 1 and 10, for example. I have only 1 and 10 in one table. In another table, I'm having 2, 3, 4, 5, 6, 7, 8. I want to search the values between 1 and 10 from another table. And then you go for range lookup. Basically, you need to select whether it's a greater than, less than, greater than or equal to, and all. This is okay. All you need to select which one is which. So this is under condition only. You need to give whether less than or greater than or less than. Okay, that's the only thing you can do in range lookup. Another lookup is, I'm just putting back to equal lookup. Another lookup is sparse lookup. Okay, where is sparse here? Okay, so here you see lookup type equal to sparse. Here, when you say normal, you have a lot of options enabled here, partitions and all. When you select a sparse lookup, automatically partitioning and optimization is done inside the database. So data storage will try to utilize the resources of database, resources from database. That is the significance of sparse lookup. Okay. So types of lookups: normal lookup, range lookup, and sparse lookup. But sparse lookup can be shown when your reference link is database only. If your if your chain link is a file, you don't see sparse lookup. It works for only databases. For example, Oracle and DB2. Okay, so there won't be, even if I select and run my job, there won't be any change in my output. Just optimization will be done on the back end. Okay, there won't be any change to output. Just performance will be increased. That's it. So now let's talk about what are the differences between. So Lookup types, normal. So let's talk about the differences between join, merge, and lookup. Then I will we can go ahead. So are you good with the lookup stage? What are the options for lookup? Then I will talk about the differences. When you do sparse lookup, automatically partition, you don't need a partition actually. So basically it will take automatically. Okay, auto partition is happening inside the database. So are you good with the lookup stage?
Now the child link is a database. We need to use the sparse lookup.
If your database is if your child link is a database, you can utilize the power of database resources. Yeah, you can use pass. But if your child link is a file, you can't use it, right? Okay. So that's about join, merge, and lookup. Let's see. So general question. So everybody asks, what is the difference between join, merge, and lookup? So let's talk about join. Okay. So when you go for join, okay, let's assume you have a large amount of data. Okay. When you have multiple tables or files, multiple tables or files with a huge amount of data. Okay. Huge amount of data. And you don't need a reject. Then you go for join, obviously. Join supports four types of join: inner join, left outer, right outer, and full outer. So what else? So you have to apply hash partition. Make sure you apply hash partition and sort the data before you join on the links. On the link partition, you can do it. Okay. So yeah, basically when to choose, that's the main point. So when you have a large amount of data, then you go for the join. That's the main answer. Okay. So it supports four types of joins. But sometimes they may ask you how to capture the rejected data by using join. So give the tell the technique we did. Okay, by using filter, uh, do a full outer join and do check, apply the filter where column is null. That can tell us when to go for merge. Okay, so when you have a huge amount of data, okay, fine, and you need a rejected data. You need rejected data from child links only. It is nothing but update links. Then you go for the this, and it supports only inner join and left outer join. Hash partition and sorting the data is a common technique. Okay, so when you go for lookup, so when one file is huge and when one file is small, then you go for lookup. When your main table is huge, main table is huge, and child links are small, very small. Okay. Okay, so when main table is huge and child tables are very small, then you go for lookup. It supports inner and left outer join. So you apply entire partition for reference link only. Reference link only, not for main link. We don't apply any partition for main link. So we have a three types of lookups. normal lookup, range lookup, and sparse lookup. Sparse lookup can be used only when reference link is database. Okay, so these are the answers you have to give. Did we miss anything? Non-merge supports and -1 reject links. And -1 reject links. Rejected data from child links only. So it supports rejected data from main table. Okay, so it's a different, right? So yeah, so when you go for merge, when you go for join, and when you go for lookup, so you have to clearly tell these things. So I want to do a join, and both, let's assume both two tables are having millions and millions of records. I don't need a reject, then I will go for join. If I need a rejected data from child table, then I will go for merge. If I need a rejected data from both tables, then I will do a join and filter technique we used. When there is a one file is huge and one file is very small, then I will go for lookup. So depends on the data scenario, you will have to choose these stages. Clear? Are any doubts in this? Guys,
Oh,
understand what is this point?
yeah. Only we need to give the entire partitions on the reference link.
That's it.
Okay.
Yeah.
For the main link, we don't need to give any partition technique.
Main link you don't need to give anything. So because main link data is going to split
Search the.
into two parts and search in the every node. If you don't apply entire partition, main link data will go to each and every node and search for the value. So we are optimizing there. You don't go to both the nodes, you just go to one node and search it, you will find it. So we are
Enter.
telling data stage, yeah, entire data, I did put entire data in every node. So why do you need to go for both the links?
Okay.
Okay. So take a snapshot. So this is very important. So it's a regular question generally asked, but
So
we
if the reference data is a database and if it is a large volume of data, at that time also we use the entire partition technique.
and you have to use a sparse lookup. You apply the sparse option.
Okay,
So
okay. At that time
optimization is
also,
done on the
yeah.
database.
Okay, okay.
You don't need to apply entire partition. Database will take care of the partition and all. Okay, that's what the sparse meaning. Instead of utilizing
Okay.
data stage resources, database resource will be utilized.
Database. Okay.
Okay. Generally,
So
we
now
don't
we
do
are
it.
now we are connecting to the database, right? Is it the one like we consider as a database, or it's
Yes,
complete?
it's a database only, right?
Yeah,
If it
yeah.
is not a database, you don't see sparse option here.
Okay.
Okay. Okay. This is about join, merge, and lookup. It's very, very important. So you have to tell these kind of answers. Okay. So maybe you can remember the option name also. What is the option name? Unmatched master mode. Unmatched master mode equal to keep means left outer join, drop means inner join. So here what is the option? Lookup on failure. Lookup on failure equal to keep or drop. So generally people says keep or drop. So what do you keep or drop? So option they will ask for what is the option name. So you have to remember this option name. Okay.
Puppets continue, Venkatesh.
Where it is continue? Okay, sorry. Continue here. Continue and drop. So here also continue. Okay, continue and drop. Okay, so these are the options. These are the answers you have to give. Okay, that's about join, merge, and lookup. Functionality is same. See, when I'm doing a whether join, merge, or lookup between employee and department, output would be same. So output will never change. But we are using different techniques. That's it. To do join. Okay. So what we can go with change aggregator is done. Change gap is done. Copy is done. Funnel we have done. Join, merge, lookup. Pivot and place is done. Modify is not done. Remove duplicate is done. Sort is done. So we haven't done a switch, transformer, SCD. Okay. Maybe let's go with the modify. Let's try to learn one or two functions in modify, but it's a manual. Okay. Okay. So you have any doubts in join, merge, and lookup? Any stages? Then we can repeat. Otherwise, I will jump on to another new stage. Good. Are you guys good? Pawan, Rakesh, Shweta.
I'm good.
Okay. So let's jump on to new topic. Are you guys practicing every day or not? If you don't practice, see how many stages we have done? 1, 2, around 10 stages we are done. You practicing, Rakesh? Working? Is your system working now? You guys,
Yes,
Pawan, you guys are joining from mobiles. So what happened to your PC? What can
working,
you?
sir. Only one class I'm working.
Only one class you practice now.
I'm practicing.
Okay. So what happened to your laptop? When you join from mobile, what can you see in mobile, man? It's very small screen and you cannot see the options there, right? Try to join from laptops. Okay, then you can see at least options when you see video next time you will remember. Okay. Okay. Yeah, let's jump on to new stage modify. So in database, commission is having nulls, right? So lot of rows are having nulls. So how do I want to display only null values? How can I do that? Select star from EMP where commission column name is null. You cannot put equal to null. Equal to null will never work. Null is not equal to anything, something like that, right? So it will not work. So you have to put where commission is null. Is null. See, there out of 14 records, 10 records are having commission null. So if I want to see where commission is not null, you just put is not null. Is not null. See, it's very easy, right? So writing queries is very easy. So now I want to change the value. Okay. Select EMP number, comma, ename, comma, commission, comma. This is a new old commission. I want to apply some technique for the commission. I want to convert commission to some value. Okay. I want to apply some value. So there is a function called NVL in the Oracle, null to value, commission, comma, 100 from EMP. So I'm saying this is a function. NVL is a function null to value. NVL of column name, comma, 100. If this column is null, 100 will be given to that value. that column. So if you see output, you will understand. You see, this is a original commission. This is a new commission after I applied a function. So what I said, if commission is null, then give the 100 rupees as a default commission. You see, if commission is not null, then the same values will be given. That's what the NVL function in Oracle does. If you want to do this in manually, how much time you will take? You will take a lot of time. Okay. In reality, there will be millions of records. So if you apply this function, automatically it will be done. So how do you do this in data stage? Okay, there are two ways to do this. Okay, in data stage. So one is modify and one is transformer. In transformer, you don't need to write any functions. Automatically, there are predefined functions are there. You don't need to write any code. Okay, but in modify stage, you have to write a functions. You have to write a code. Okay, so you can choose whichever you want. Generally, we go for transformer, but we did not start that stage. I will talk about that stage later. For now, let's go ahead with the modify. For example, I will show the difference. If you go to transformer, just a sample, don't worry about it. I'm just showing. If you go to function, you see null handling is null, is not null, null to value, null to 0. Already here in Oracle, you wrote it. In data stage, they are already written and showing. You just have to use them. That's it. That's what the use of ETL tools. You don't need to write any code. But if you want to write a code, yeah, you can write it. They are giving you chance to write it. So let's try to write one function for handling nulls. So emp, where is my employee table? Okay. So let's add the parameter set also. So here here you need to tell commission equal to handle underscore null of commission comma 100. So in data stage, this is the formula. If you want to write manually, if you don't remember it, just use the transformer stage. You don't need to worry about it. But I just want to show you the example in modify stage. So commission equal to handle underscore null commission comma 100. And other part is that's it. That's the only specification. Instead of this, you can write. So modify stage supports different conversions also, functions also, but you have to write them manually. Okay. So I'm just showing one example here. Okay. It is used to keep the columns, drop the columns, rename the columns also. Okay. So, but yeah, just go ahead with this option for now. If you go to output, you cannot say anything. Mapping, it will not show anything. So simply you can load the employee plugin because we are reading employee, right? Just load everything. Okay. Input and then output. I just loaded the column because modify stage will not show the mapping option. So you have to select the column. You have to select the columns manually. So that's why I have loaded it. And then output file. Browse for file. Let's give a parameter. That's it. So let's try to run and see. So what this function is doing? So I'm telling, okay, come in the commission column, apply this handle. If you have any nulls, you just give 100 rupees. That's what this function I have telling. So let's try to view the data. What you see here, it is having 100, right? Wherever it had nulls, now it is 100 default commission. That's how you can make use of with the modify stage. I mean, there are other uses also. But yeah, generally we don't go for this because it's a manual stage. You have to write the functions. You have to remember and write the functions. So instead of going with this, generally we go for transformer stage. There you can pick all the existing functions and syntaxes instead of writing manually. Okay. So yeah, so see we're almost done. Now only we are pending with the transformer. Okay, transformer switch. I will tell tomorrow. If I go with multiple stages in one day, then you can't practice. And surrogate key and slowly changing dimension. So these are the 4 stages left in parallel. Okay, so and then we go to these stages: development and debug. Uh, Transformer will take 2 to 3 classes. Switch and the surrogate key we can do in one day. Slowly changing dimension one day, and these things in one day, and then we can go for sequence jobs next. Okay. Make sure key thing is to practice here. Okay, nothing else. It's just a tool and options, right? I will stop this recording and share when it is ready.